Hello everyone, my name is Jarrell Green, a part of Team Australia, and today I'll be giving you a cyber operations and risk management briefing. This is the agenda for today's briefing. I'm going to start off with a brief introduction, then we're going to talk about software assurance needs, the software development lifecycle, supply chain risk, vulnerabilities, software options, recommendations, and I'm going to display my references. A significant part in ensuring the integrity of programs, networks, and systems is understanding risk and how to manage those risks that have been identified. Risks are aspects of cybersecurity that are inherited by the use of innovative tools that aim to increase operational efficiency and provide a level of simplicity for daily operations. It should be reiterated that as technology advances, so does the capability and determination of external entities to upgrade their attack capability to penetrate said new technology. Because of this, risk management should be at the forefront, especially when implementing new and improved technology. Not only does this apply to hardware, it also applies to software. Thus, the use of innovative software adds the burden of ensuring quality software assurance to maintain the integrity of programs and the information that the programs are being used for. According to Laidlaw and Schumacher, software assurance is the explicitly designed and implemented function that ensures the specific security goals of the organization will be maintained. In other words, it is the work of an organization to ensure that the software deployed throughout a network meets the physical and cybersecurity rules that are in place. During the global summit, it is the goal of Australia to ensure that their software accomplishes four main objectives. The first is ensuring that all software programs are updated and regularly patched to lessen the chance that an attacker will exploit known vulnerabilities. The second is ensuring that all software source code is vetted and validated prior to implementation. This ensures that the software is verified by the manufacturer and free of any attempted attacks. Third, Team Australia will ensure that only software relevant to the Global Summit will be implemented throughout the network. This will ensure that the attack surface is minimized to the smallest extent possible. Finally, Australia will ensure that each member of the team is educated on the dangers of malware and its prevalence within software applications. In addition to these methods of ensuring software assurance during a global summit, it is also important to implement the software development lifecycle. According to Kumar and Dubey, software development lifecycle methodologies are mechanisms to ensure that software meets established requirements. This is accomplished to ensure that the software being provided is of the highest quality and performing its designed function. The cycle is comprised of 7 different phases, all of which serve the purpose of progressing the development of software and ensuring it is preserved, altered, and enhanced according to its ability to fulfill its purpose and function. The planning phase begins the process by gathering requirements and identifying the scope of the software and its intended function. During the analysis stage, the concept of the software is evaluated for its feasibility and validity. Additionally, software, hardware, and network requirements are then determined. The design phase of the cycle includes the design of the software, the user interface, security mechanisms, and databases. It also determines the system architecture approach and how the software will be coded. The development stage is when the production of the software begins based on the parameters that were set in the first 3 stages. The testing phase ensures that the software is free of bugs, flaws, and meets the intended goal outlined in the beginning of the process. If the software fails during testing, the steps are repeated until the product meets the goals. Once the software has passed the testing phase, it is implemented for the organization and released to all vested parties. Maintenance is an ongoing process after the implementation and is responsible for ensuring that all identified issues are resolved. Additionally, this phase releases patches and updates to fix any identified vulnerabilities. In addition to the software development lifecycle, the software supply chain should also be considered. As Iridir states, the whole software supply chain is a target for attackers, and it is really important to make sure that we put all our effort into securing each link because if one fails, everything will be affected. The software supply chain describes the chain of events that occur throughout the software development lifecycle from the development of the software, including all hardware and software components, to the delivery to the end user. There are glaring holes that can be identified within the software supply chain that could be catastrophic for an organization. For example, foreign electronic components can be programmed with malware or spyware systems that can collect data from software it was made to be compatible with. Additionally, a software patch could be altered prior to the deployment and infect the software with malware. The fact is that the security of the supply chain is determined by the risks that are taken during the development of any given software. From its conception to its delivery, software can be impacted from a number of different factors. It is in taking calculated and evaluated risks that security can be ensured while ensuring the delivery of services. During the global summit, it became apparent that one of the biggest risks that existed within the network was the human use of the software. As seen in the most recent attacks using Microsoft Excel, an attacker was able to launch a ransomware attack by deceiving the user that a software application update needed to take place. It is important to mention that vulnerabilities exist in each software application that may be used, as no system or application is immune from attack. This is especially true for Australia, as government entities serve as high-value targets for attackers looking to do the most damage. Microsoft applications like Excel and Outlook have vulnerabilities that allow attackers to execute denial of service, man in the middle, and malware attacks on the network, as seen during the Global Summit. Regardless, in this case, human error and lack of risk management proved to be the most glaring vulnerabilities on the network. Although the use of software comes with inherent risks, there are software options that can be used to mitigate and counteract those risks. The use of software security tools can help Team Australia consider the risks that are associated with their use of software during the Global Summit. Our software options include McAfee Total Protection, which is a licensed antivirus software that is used to scan applications, files, and other aspects of the system for presence of malware, viruses, and trojans, and other attempted attacks on the network or system. AppLocker is a software that comes with the Windows Server deployments and allows for whitelisting and control of software that is used and implemented on the systems within the network. Manage Engine Analyzer is a software that serves the purpose of analyzing system logs on all devices within the network and providing status reports and analysis of events recorded. It can also be combined with intrusion detection and prevention systems to further harden the network. OSSEC is an open source program that serves as a host-based intrusion detection system that can be installed on the system and used to monitor the activity on the system. Finally, we will move on to the recommendations section. First, the software options provided each provide a specific capability that can be added to the network. McAfee Total Protection is important because with the recent malware attack on the network, the need to scan software files, applications, and other systems components is a must to ensure that the system is free of malware, trojans, worms, and other forms of attack. AppLocker is important because by creating a whitelist, Team Australia can control the applications and software that are being used on the network. The third application, Manage Engine Analyzer, is important because system logs can provide a lot of useful information about the state of the network. Having a tool that automates this process can help focus the analysis on the information found by the system. OSSEC is important because open source tools have significant advantages that can include the savings of cost and the community of people that can help tailor the program to the organization. OSSEC can be used to specifically tailor rules and parameters that fit the need of Australia during the Global Summit. The securing of the supply chain proves to be more difficult for Team Australia due to the number of variables that exist. Security of the supply chain does not start with the securing of one workstation, as there are many steps that are taken before that point is reached. Instead, securing the supply chain involves each component involved in the development of software and the protection of the integrity of the software throughout the entire process. Extreme solutions like internalizing each aspect of the supply chain, like the production and development of hardware and software, in addition to the software being developed, is far from practical. Instead, it's recommended that Team Australia develop a risk management process that weighs the positives and negatives associated with different aspects of the supply chain. For example, the use of hardware that is compatible with developed software. It is recommended that the government weigh the risk of using hardware that is domestically developed versus outsourced software from countries like China.